Hi folks, welcome back. I hope you're all doing well. Continuing with the theme from the last few videos, I'm gonna look at another paper that dives into the technique of retrieval augmented generation with large language models. The applications of LLMs fall into two very broad categories. The first one is more creative, where you're trying to generate creative new text that doesn't necessarily need to be factual or grounded in reality. If you're trying to generate names for a company or play around with short story ideas, things like that. The other big category is where you want to use LLMs to synthesize answers to domain-specific questions grounded in your private corpus of documents. There you want the answers to be truthful, factual, not contradict the facts that are present in your corpus of documents. That application is called long-form question answering because you want the LLM to generate paragraphs and complex answers to domain-specific questions. By now, the somewhat standard way of doing that is retrieval augmented generation, where you first do a retrieval step of finding documents relevant to the user's query, and you append that to the prompt along with the user's query and give that to the LLM to synthesize its answer. Now, while that's a pretty commonly used technique, it is still pretty new, and we're still discovering all kinds of quirks in that general technique. For example, in a paper that we looked at in this channel a few weeks ago, researchers found that information at the beginning and end of the prompt is used much more heavily in the synthesized answer. So where you put your retrieved documents within your prompt matters quite a bit for the quality of the answer. The big new contribution of the authors in this paper is doing a bunch of controlled experiments with retrieval augmented generation. And they do two types of experiments, which you can see in this diagram. The first one is where they hold the retrieved documents constant and vary the underlying LLM used to generate answers. So in that set of experiments, they're seeing which LLM generates better answers by some metric. The second class of experiments they do is they hold the LLM constant, but change the nature of the documents that are fed in during the retrieval phase. So they take some relevant documents, they take partially relevant documents, and then they even do an experiment with completely irrelevant documents, and then look at the quality of the answers. So let's quickly look at how they set up this experiment before we look at their results. They start with the Eli 5 data set, Explain It Like I'm 5, which is a subreddit, and that is their input set of questions that are being asked. Now, for the document sets, the underlying ground truth that's being used as evidence, they construct 4 different sets of documents. The highest quality one is gathered by humans, by trained annotators. They do use search engines, but they also apply their own judgment. Another set uses the WebGPT retriever. Now, WebGPT is a fine-tuned GPT variant created by OpenAI that was trained while using retrieval. So it had a browser to use while it was being trained in question answering. So it's a bit of a different LLM compared to the others because it has been trained specifically for this. The third set was just using a web search engine. And finally, they used some random irrelevant documents. So that's how the study was set up, but what are the metrics we're looking at? They're looking at some metrics that are automatically computed from the answers themselves. One of them is self-blue, which is a measure of the diversity of text. You're basically trying to see if the LLM is mindlessly repeating the same thing over and over again in its answers. So you want diversity to be high in good answers. Another one is perplexity, where lower perplexity means the text is more fluent. But this is not a great measure because often human written text will have high perplexity. But those are all fairly synthetic measures. The thing that you really care about in a RAG experiment for long-form question answering is attribution. You want the answer generated by the LLM to not contradict your underlying corpus, to not contradict the relevant retrieved documents that were put into the prompt. You want every utterance in the answer to be able to be traced back to a document in your relevant set of documents. Now, that attribution task is actually pretty hard to do, and in this experiment, the authors used humans to judge the attribution of the answers. And they looked at all these answers, and they looked at every sentence in the answer and came up with a judgment that said one of three things. The answer was supported by the documents, it was partially supported, or it was not supported. So that's the measure you really care about, whether the answer is attributable back to your documents. So let's jump straight to the attributability of the generated answers. And you can see in this table that WebGPT does really well. It had 95% of its answers being supported by relevant documents. GPT 3.5, when using WebGPT for retrieval, comes in at around 85%. And you can see that without documents, GPT 3.5 gets an abysmal 22%. So you can still see some problems with retrieval augmented generation in that even in the case where GPT 3.5 is given relevant documents, you have about 15% of its utterances not grounded in those documents. So it's using its own world knowledge, its parametric knowledge, beyond those documents. Another interesting question to ask is how the order of documents affects the order of information or the quality of the generated answer. And here they find something interesting. They find a linear pattern, which means that information that was presented earlier in the prompt also tends to appear earlier in the generated answer. Moreover, they also find this drop-off effect where sentences earlier in the answer tend to be better supported by the evidence in the prompt. They find that the last sentence is almost twice as likely to be unsupported compared to other sentences in the answer. So you might ask, when the answer generated is not attributable, it's not grounded in the evidence documents that you provided, what went wrong? So there are three possibilities. One is a failure of retrieval, where the documents that you retrieved to put into the prompt simply were not relevant to the user's query. Another possibility is that the LLM hallucinated facts. And the third possibility is that the synthesis was incorrect, that you did find the relevant documents to put into the prompt, but in spite of that, the LLM synthesized something that was not grounded in those documents. And in this table, they give the results of a study of the frequency with which these things happen. And what they find is retrieval failure and hallucination are the most common, with incorrect synthesis trailing by a large margin. So that was a quick look at a paper that did a bunch of controlled experiments to tease out how retrieval augmented generation with LLMs behaves. And it's interesting to see that even though it's a fairly well-established pattern with LLMs to use retrieval augmentation, we still don't understand a ton about how it works and what the properties of these generated answers are. I hope you enjoyed that. If you like content like this, please consider subscribing, like the video, and I will see you next time. Thank you very much.